So here regression equations x on y and y on x from assumed mean method. So this also same as it is what we done for correlation analysis, the same procedure, same method. So first of all, what we have to do, we have to calculate the x bar value and y bar value. If the x bar value is in fraction or decimal, so we have to uh, decide that we need to decide that this method is belongs to a assumed mean method. Okay, assumed mean method. So this is a formula. X minus x bar is equals to r into standard deviation x by standard deviation y into y minus y bar. Okay. So here you focus carefully here. See this place r into standard deviation x by standard deviation y. So this will be written like this. Sigma dx into dy minus sigma dx into dy by n divided by sigma dy square minus dy whole square by n. Okay. So this is a question. From the following data, obtained two regression lines. See, two regression lines we have to obtain. X values and Y values are there. 2, 6, 8, and double one, 13, 13, 13, then 14, 8, 6, 10, 12, 12, 14, 14, 20. And this is the solution here. X and Y values. So just to do the total, X totals and Y totals. So go for finding out the value. Okay, X bar value you have to find out. After finding X bar value, you got a different value. So take assumed mean. You can take any number. So I am in this problem, I am taking this 2 and 8. Okay. So 2 minus 2, that is 0. 6 minus 2, 4. 8 minus 6, 8 minus 2, 8. 2. 11 minus 2, that is 9. 13 minus 2, 11. 13 minus 2, 11. 13 minus 2, 11. 14 minus 2, 12. Sigma dx is equals to 64. The next is 0 square 0. Okay, 4 square dx square. See this place and this place. Dx is 0 square 0. 4 square 16. 6 square 36. 9 square 81. 11 square 121. 11 square 121. 11 square 121. 12 square 144. So sigma dx square is equals to 640. Okay. The same procedure apply for the dy also. So dy here, see 8 8 minus 8, that is 0. 6 minus 8 minus 2, 10 minus 8, 2, 12 minus 8, 4, 12 minus 8, 4, 14 minus 8, 6, 14 minus 8, 6, 12 minus 8, that is 12. So sigma dy is equals to 32. Okay. So after getting all these values, see, after getting all these values, 0 square is equals to 0, 2 minus 2 square is equals to 4, 2 square is equals to 4, 4 square is equals to 16, 4 square is equals to 16, 6 square is equal to 36, 6 square is equal to 36, 12 square is equals to 144. So sigma dy square is equals to 256. 256 is the sigma dy square. The next one, sigma dx and sigma dy. 0 into 0, 0. 4 to the 8, 8. 6 into 2, 12. 9 for the 36. 7 for the 44. 11 6 to 66. 11 6 to 66. 12, 12 the 144. Sigma dx into sigma dy is equal to 360. Okay. So after getting all these values, so what is our formula? Just remember the formula and interpret the values into the formula. So this is the formula, regression equation, x on y. X minus x bar is equals to r into standard deviation x by standard deviation y, y minus y bar. The value of x minus x bar is equals to r into standard deviation x by standard deviation y, y minus y bar will now be obtained as follows. That is, instead of writing r into standard deviation, see standard deviation x by standard deviation y, simply r into dx divided by dy. You have to write like this. Again, this will be written as this also. Sigma dx into dy minus sigma dx into dy by n divided in tu sigma dy minus dy square minus dy whole square by n. So this is the formula. So according to the formula, interpret the values. So already we got the values. Okay. So these are the different values. Sigma dx square is equal to 640. Sigma dy square is equal to 256. Sigma dx into dy is equal to 360. Sigma dx is equal to 64. Sigma dy is equal to 32. Okay. So here sigma dx into dy 360. 64 into 32 by 8. 256 minus 32 whole square by 8. So finally, we are going to get the value that is 0.812 is 0.812. So this in the place of here, see r into dx divided by dy, that is 0.812. X minus a is equals to 0.812 into y minus a. Okay. See in the for the actual mean problem, x minus x bar we have taken. In the place of x bar, simply you need to take a only. A means assumed mean value. Okay. So y bar, instead of y bar, a value that is 8. So finally you are going to get like this. The answer is okay. That is x on y. Then y on x. This is the y on x. See, already values we got, but little bit formula will be changes here. R into dy divided by dx is equal to sigma dx into dy by the sigma dx into dy by n divided by sigma dx square minus sigma dx whole square by n. Okay, so you observe carefully here. See, after getting all the values, sigma, that is regression equation y on x. 360 minus 64 into 32 by 8 divided by 64 minus 64 whole square by 8. Okay, 0.812. Same answer you are going to get. So in this way, the calculation will be done. Okay, so y on x also completed. Then after completion of y on x, coefficient of correlation is equals to under root bxy into byx. Okay, that is 0, my under root 0.812 812 into 0.812, that is, okay, 0.8 final answer. Okay. So this y on x also completed. So this is one problem. Okay. So take a photo. The following table shows the ages x and play pleasure of 8 persons. That is x and y. 52, 63, 45, 36, 72, 65, 47, 25. Then y values 62, 53, 51, 25, 79, 43, 60, 33. Obtain the regression equation of x on y and y on x. See, like this, the question will be there. Obtain the regression equation of x on y and y on x. So, if coefficient of correlation is not mentioned, so no need to do. Okay. If coefficient of correlation is given means you have to do. Otherwise, not required. So at this, we completed correlation analysis and regression analysis. So anybody, if you have any doubt, you can ask doubt. So now I will go to the new topic. Anybody you have any doubt? Bharati, Radha, Kalyani, and this VOV 2143. Okay, right. So
Yes.
I'm okay. So we will see once syllabus. Yes. So here already we completed the till block one completed, and in the block two, see in block two correlation regression completed. So this business forecasting is theoretical part. You can get the notes. Okay. So in the okay. Hmm. In the block four, statistical estimation and hypothesis testing. So this is also problematic part. So in this problematic part, we are going to see you remember 13, 14, 15, 16. After completion of 13, 14, 15, 16, we'll go for chi-square test. Okay, chi-square test also very simple and easy. Okay, so I will share the screen. Wait. Right. Okay. So wait a minute. The introduction to testing hypothesis. So introduction to testing hypothesis, central limit theorem, population, sample and sample distribution, test of hypothesis, the concept of standard error, type 1 error and type 2 error, two-tailed and one-tailed test, estimation, hypothesis testing procedure. Okay. So this is complete theoretical part. So you will be, you can get the notes from SP Gupta book also. So first, we will discuss this hypothesis testing procedure. Okay, so see this one, hypothesis testing procedure or steps in testing hypothesis, we can say. So first, before we are going to do the problem, so testing hypothesis is most important here. Okay, so some steps are there. Uh, we will go for a small discussion in that steps. And then after completion of testing hypothesis, we go for unit number 14, that is testing of significance of attributes, then large sample, then small samples. Okay. Then t-test is will there, then chi-square test. Right. So here sampling and testing hypothesis. So statistical inferences is that branch of statistics which is concerned with using probability concept to have to, to has with uncertainty and decision making. The field of statistical inference has had a fruitful development since the later half of the 19th century. It refers to the process of selecting and using a sample statistic to draw inference about a population parameter based on a subset of it, the sample drawn from the population. So statistical inference treats two different classes of probability, that is here hypothesis testing and estimation. So to test some hypothesis about parent population from which the sample is drawn, and estimation is nothing but here. It is used in the statistics to obtain from the sample has estimate of unknown parameter of the population from the which is drawn. The parent population, from the parent population we are going to get the information about the sample what we is drawn. Then estimation also, in estimation unknown population will be known, unknown parameter. Okay. Then see hypothesis testing. Hypothesis testing begins with an assumption called a hypothesis that we make about a population parameter. So generally, what is hypothesis? Anybody? Hypothesis. Hypothesis. Yes, hypothesis is what?
Don't know, sir.
Okay, so listen here. Hypothesis is a supposition made as a basis for reasoning. Hypothesis is nothing but a small assumption, okay, or imagination, or we can say sometimes it is a blueprint also. So Palmer O. Johnson has beautifully described hypothesis as islands in the uncharted seas of thought to be used as basis for consolidation and recuperation as we advance into the unknown. So unknown things will be knowing to us. And there are several types of hypotheses. For example, a coin is tossed 200 times and we may get heads 80 times and tails 120 times, or may now be interesting in testing the hypothesis. So here the hypothesis that the kind is unbiased. Okay. So here the parameter means nothing but a limit defining the scope of an activity, and recuperation means recovery from illness and regain. So you observe the procedure of testing hypothesis. So these are the five steps are involved in testing the hypothetical procedure. Okay, so this procedure you have to carry for examination point of view in your mind. Okay, so if you had these steps in testing hypothesis, then you are going to get good marks. So for short bit also, testing hypothesis question will comes. What are the steps involved in testing hypothesis like that? Okay, so here A null hypothesis H naught mu is equal to H naught. It is very clear. It is very useful tool in testing the significance of difference. Hence, the word null, which means invalid, void, or amounting to nothing, and that the difference found is accidental and VD, important. Void, important, assign out of fluctuation of sampling. That is null hypothesis. Then alternate hypothesis, HA, mu is not equal to H naught. However, for statistical convenience, okay, it will make a difference as to which hypothesis is called null hypothesis and which is called alternative hypothesis. Okay, so the next second step is setting suitable significance level. So you have to remember like this: testing hypothesis, setting suitable significance level, test criterion, do a calculation. The last step is conclusion. Okay, so here is setting suitable significance level. So here, having set up the hypothesis, the next step is that test the validity of H naught against that HA at a certain level of significance. So here you have to remember two important points. See, this is the two important points. So generally, okay, you listen carefully. So this is a normal curve. So here 5 percentage and that is significance level, 95% is confidence level, that is 1.96, and 1% is significance level, that is 99%, confidence level 2.58. Okay, what is this 1.96 and 2.58? Okay, so here when you are calculating the problem, okay, if in the given question LOS 5 percentage is given means you have to consider 1.96. This is the critical value. This is the critical value. 1.96 is the critical value for 5 percentage and 2.58 is the critical value for 1 percentage. You have to remember these values. You have to remember these values. Otherwise, you are going to lose the marks. Okay, see why? Because yesterday in the ANOVA problem, what we done? 5 percentage, 1 percentage. Already one table values are there. Okay, table values are there means here. So the calculated value, we done calculations. Okay, we done the calculations. Then for that calculated value, say comparison is important. So we need to take the decision. So the calculated values compare with the table values, that is TV or critical value. So for ANOVA is the table values there. And for see, these values are the critical values. These values are critical values. 5 percentage LOS and 1 percentage LOS is given in the question means if 1 percentage given means 2.58 is a critical value for comparison. So here we are going to compare like this. Calculated value CV will be compared with the table value or critical value. You can say CV critical value 2.58. Okay. So 5 percentage LOS is given means
One.
1.96 is a critical value. Okay. So in this way, you have to calculate
Yes.
after completion of this step. So in this step only, we have to decide that 5 percentage, 1.96 or 2.58 have to check. Okay. Wait a minute. So then after this, see, after second step is completed, go for the test criterion. Test criterion is here in the test criterion, we need to write the formula, the method, everything here only. The next one is doing calculation or computation. So we are going to do the calculation or computation here. So after calculation and computation is completed here, see, uh, here is the important here. So here this value is called as calculated value. This value is called as calculated value. We done the calculations. Who done the calculations? We done the calculations. So that is the calculated value. So that calculated value should be compared with the critical value 1.96 or 2.58 is the critical values. If in the given question 1% is mentioned means 2.58 critical value. Okay. 5% if we mention means 1.96 is the critical value. So that calculated value should be compared with critical value at this stage. If calculated value is less than the critical value means the null hypothesis will be accepted. Otherwise, it will be rejected. Okay, otherwise it will be rejected. Okay. Finally, in the fifth step, the small conclusion will be written. So now we will do one problem. So you will get the complete, your doubts will be solved clearly. So the next one is estimation here. So you can take the photos also. So, estimation, when data are collected by sampling from a population, the most important objective of statistical analysis draw inferences or generalization about the population from the information carried in the sample. Statistical estimation is concerned with the methods by which population characteristics are estimated from the sample information. Then it may be pointed out that the true value of parameter is an unknown constant that can be correctly ascertained only by an exhaustive detailed study of the population. Statistical estimation procedure provide with the mean of obtaining estimation of population with a desired degrees of precision. The following two types of estimations are possible, that is point estimate and internal estimate. So estimation is important. By doing this problem, we can automatically estimate. So here point estimate is important here. A point estimation is a single number which is used to estimate the unknown population parameter. So with the help of point estimate, we are going to know the unknown population parameter information. Then interval estimate. An interval estimation of population parameter is statement of two values between which it is estimated that the parameter lives. And interval estimates would always, okay, satisfied and specified by two values, such as lower value and higher values. In more technical terms, interval estimation refers to the estimation of parameter by a random interval is called as confidence interval. Okay. The next one is properties of a good estimator. So now we are entering into the problematic part here. So properties of a good estimator. The following are the properties or characteristics of a good estimator. That is unbiasedness, consistency, efficiency, and sufficiency. Unbiasedness means anybody? Unbiased means what? What is unbiased?
Don't know, sir. First time listening.
Okay, unbiased. You are listening the first time. So listen here. నిష్పక్షపాతంగా లేకపోవడం అంటారు చూసారా అన్బయాస్డ్. Okay. So while you are taking any decisions, don't do any favor to your friends. For example, one incident has happened. So in that incident, your close friend is involved and other persons or unknown person was there. So at that time situation, you will be the person to take a decision. So at that time, what type of decision you are going to take? So here, okay. So you should play a role like a unbiasedness. Unbiased means here, for example, a coin is a tossed. Okay, a coin is tossed. Okay, a coin is tossed. Suppose if you get a head or tail, okay, head or tail, mm, uh, then the information is known into advance. Suppose you tossed a coin, the information is known to advance means that is a biased. So coin is a unbiased coin. Why? Because coin don't know anything. Okay, you can toss it. Anything will come. The result will be positive or negative result. Means here. Okay, here kind, unbiased kind. So kind don't know. Kind never play a positive role or negative role, and kind never play a favorism towards that concerned personality. Okay, so kind వేసే క్రమంలో ఏమవుతుంది ఏదైనా రావచ్చు హెడ్ రావచ్చు టేల్ రావచ్చు kind pay unbiased yes. Then consistency means here suppose you are taking any type of decision, a consistency is required. Then efficiency means what are the resources are available. Okay, what are the resources are available. So with that resources maximum you need to utilize. Okay, with a minimum investment you can get more maximum profits. That is efficiency. You have to prove yourself. Then sufficiency means the what data is available, sufficient data should be collected. Which relevant data is collected only. So exact which type of data is required for us, that data we need to collect it. Don't go for irrelevant data. So relevant data should be collected. Okay. So these are the properties of good estimator. The next one is here types of testing significance. See, for in different universities like Kakti University, for MCOM and MBA students, is put together one chapter. Put together one chapter. But for Ambedkar University, this is a one chapter, this is one chapter, and this is one chapter. It is divided. So generally, this hypothesis is a good chapter and a big chapter. It takes more than 20 days time. Okay. So for your convenient purpose, Ambedkar University people, what they done, they divided this chapter. So for your convenience, it is good. Okay. So now we will see test of significance for attributes. This is a new chapter. Okay. New chapter in the sense, the chapter number for unit number 14, that is test of significance of attributes. Test of significance for attributes. Okay. After completion of that, we will see test of significance for variables, large samples, test of significance for variables, small samples. Okay. Test of significance for attributes. The various tests at significance for attributes are discussed under following heads. Okay, again, test of significance for attributes are divided into three topics. three subtopics. That is test for number of success, test for proportion of success, test for difference between proportions. Okay. Test for number of success, test for proportion of success, test for difference between proportions. So first one is here, test for number of success. The sampling distribution of number of success follows a binomial probability distribution. Hence, its standard error is given by the formula. Standard error number of success is equals to under root NPQ. N is equals to size of samples. P is equal to probability of sample success. P is equals to 1 minus P, that is probability of failure. Then standard error is equals to difference divided by standard error number of success. So for this method, see, first we are doing. So this formula you need to add. Then this formula also. This formula is called as calculated value formula. CV formula, calculated value formula. So here N is equals to in the size of sample. P stands for probability of success. For example, you toss a coin. The outcome is called a head or tail. That is a success. Okay. See, first you imagine that I am tossing a coin. I want to get head, but tail sometimes we are going to get. So the outcome is called as probability of success. Then Q is the probability of failure. Okay, Q is the probability of failure. So we'll see the problem. Here problem. Coin was tossed 400 times and head turned up 216 times. Test the hypothesis the coin is unbiased. So here a coin was taken by one XYZ personality and they tossed that coin 400 times and turned up 216 times. Okay, turned up 216 times head. Then simply the question is that test the hypothesis the coin is unbiased. So I have a doubt on the coin. Why? Because 400 times you tossed a coin, but 216 times they got head. Okay. Why 216 times they got the head means the coin is unbiased. So we have to prove that whether the coin is unbiased or not. Okay. So the steps are there. Testing hypothesis, see, setting hypothesis, setting suitable significance level, test criterion, doing calculation, then decision. Okay. These are the steps. So first one, setting hypothesis, that is A, null hypothesis, B, alternative hypothesis. A, that is null hypothesis, H naught, mu is equal to H naught, sign is unbiased, you have to write like this, sign is unbiased. Then alternative hypothesis, HA, mu is not equal to HA, that is rejected. Then next one is setting a suitable significance level. So see, in this problem, I have written two LOS values, but we'll consider only one. For your understanding purpose, I have written A, B here. So you observe carefully. So in the given question, LOS, see, LOS, that is 5% or 1% is not given. LOS means 5% and 1% is not given in this problem. So what we have to do? We have to imagine that, assume that 5% only we need to consider. Okay, so at 5% significance level, 95% is confidence level, that is 1.96. Okay, 1.96 is the critical value. Then at 1% significance level, 99% confidence level, that is 2.58. 2.58. So we will consider only this one. So in examination point of view, no need to write this one. So you can write only one, that is 1.96. Okay. And test criteria. See, standard error of number of success is equal to the test criteria. What we have to do? We have to write the formulas according to the question. Which formula area we are going to apply? That formula should be written here. So standard error number of success is equal to under root NPQ. N is equals to size of samples. P is equals to probability of success. Q is equals to 1 minus P, that is probability of failure. Standard error is equals to difference divided by standard error number of success. Standard error number of success. Okay. So here doing calculation. So doing calculation part is important here. So listen carefully. See, when a coin is unbiased, see, I am saying that coin is unbiased, not a biased coin, unbiased coin. The probability of success means equal to tails. This is 1 by 2 of the total sample means 200 times heads and 200 times tails. So 400 into 1 by 2 is equals to 200. Generally, a coin is tossed 200, 400 times. So in that 50%, 50%, that is 200 and 200. 200 times heads, 200 times tails. Generally, when you observe, okay, first when you observe that a coin is tossed 400 times, if you divide 50, 50%, so you are going to get 200 and 200. So here, listen carefully. Standard error number of success is equals to under root NPQ. This is formula. N is equals to total number of times the coin stock, that is 400. See, P is equals to probability of success. Probability of success, that is 216 of value. So Q is equals to 1 minus P. That is 1 minus 1 by 2. P stands for this one. Okay. So 1 by 2. So it is, should be converted into the principal. Standard error number of success is equals to under root NPQ. So under root NPQ, that is 400 into P in the place of P 1 by 2 and in the place of Q, that is 1 by 2. 1 by 2. So 400 into 1 by 2 into 1 by 2. That is 100. Under root 100. Under root 100. Then it is 10 only. It is 10. Okay. It is 10. అండర్స్టూడా ఇక్కడ అర్థమవుతుందా నాన్న అర్థమైందా లేదా ఒకసారి జాగ్రత్త వినండి
అర్థమవుతుంది సార్.
Okay. So here under root 400 into 1 by 2. See 1 by 2 why we have taken means P, that is success, and Q is a failure. So in 1 rupee of value 1 by 2 50% and 50%. Okay, under root 100. Okay, finally we got 10. Finally we got 10. So difference is equals to C. Difference is equal to 216 minus 200. This 16 is the difference value. Sir, this value how we got means here. See, consider only the probability of success. Don't consider failure. Okay, the
ఓకే.
probability of success is 216. If you see, listen here, while what we done, half value is 200, I said. Half value is 200 and half value is 200. But here, success rate is important. Okay, success rate is important. So consider only 216 only. 216 minus 200, that is 16 is the difference value. So standard error is equals to difference divided by number of success. That is 16. 16 divided by uh, standard error number of success, that is 10, is equals to 1.96. 1.6, sorry. 1.6. This is the calculated value. We done the calculations. We done the calculation. So that is a calculated value. Okay, that is a calculated value. So after getting the calculated value, see, decision we have to write. Decision means last step. Decision rule we can say, comment we can say, conclusion we can say, or decision also we can say. The calculated value 1.6 is less than the table value of 1.96 at 5% significance level. Hence, the null hypothesis H naught will be accepted. That there it can be concluded that the coin is unbiased. In this way, we have to write. Okay. Any doubt, anybody?
నో సార్.
ఓకే అర్థమవుతుంది కదా నేను డౌట్ ఉంటే అడగండి అమ్మా
ఎస్
మళ్ళీ
సార్.
ఓకే అర్థమైంది కదా
ఎస్ సార్.
ఓకే రైట్ సో నౌ ఐ మూవ్ ది నెక్స్ట్ ప్రాబ్లం సో ఇన్ దిస్ వే దిస్ 1.96 we have to take for calculating the calculating purpose as well as we need to take the decision also.
ఓకే.
Right. The next problem, say this one, you observe carefully. 240 heads and 160 tails are obtained in tossing a coin 400 times. Does this appear to be unbiased coin or not? See, 240 heads and 160 tails. A coin is tossed 400 times. That 240 heads and 160 tails. Okay, so don't focus on 160. Just Ignore this one. Forget this one. Focus on only 240. Probability
Okay.
of success. Focus on probability of success only. Okay. Why? Because if you calculate 240 and 160, you are going to get 400. Already we know. But at the time of taking the difference, standard error is equals to difference divided by number of success, then you will get some doubt. Okay. So here focus only on 240 only. Focus on only 240 only. Why? Because this is the heads. Heads indicates probability of success. Heads indicate probability of success here. So the same procedure. The first step is setting hypothesis, setting suitable significance level, test criterion, doing calculation. Then next one is here decision rule. Okay. So setting hypothesis. Setting hypothesis, that is null hypothesis. Null hypothesis H naught. Mu is equal to H naught. Chi is unbiased. Alternative hypothesis HA. Mu is not equal to HA, that is rejected. Then setting a suitable significance level. At 5% significance level, that is 95%. Confidence level is 1.96. Okay, in this given question also, 5% LOS and 1% LOS not mentioned. So I am writing two times, that is A and B, 1.96 and 2.58. But you need to consider only 1.96 only you have to consider this one only. So don't consider this one. Ignore this one. The next test criterion, standard error number of success is equals to under root NPQ. NPQ. N is equals to size of samples. P is equal to probability of success. Q is equals to 1 minus P, that is probability of failure. Okay, probability of failure. Then next, doing calculation. So doing calculation part is important. So in the test criteria only, we have to decide that this problem belongs to which method. Okay. Then doing calculation. So you once again you listen carefully, Nana. See here, when coin is unbiased, the probability of success means equal to tails. This is 1 by 2 of total sample means 200 times heads, 200 times tails. So 400 into 1 by 2 is equals to 200. Standard error of number of success is equals to under root NPQ. Okay, under root NPQ. N is equals to 400. Then P is equals to, say, success only 240. I am focusing on 240 indicates half value. Okay, Q is equals to 1 minus P. That is 1 minus 1 by 2 is equals to 1 by 2. 1 minus 1 by 2 is equals to 1 by 2. Okay, so it should be converted into the principal. So here standard error of number of success is equals to under root NPQ. This is a formula. Under root NPQ. P stands for probability of success. Q stands for probability of failure. So 400 is the total number of times the coin is tossed. That is 400 into, yeah, P is equals to 1 by 2 and Q is equals to 1 by 2 is equals to under root 100. Then you will get 10. So difference is equals to 240 minus 200 is equals to 40. So standard error is equals to difference divided by standard error number of success is equals to 40 by 10 is equals to 4. So 4 is the calculated value. So here decision will be like this. You have to write the calculated value 4 is greater than the table value 1.96 at 5% significance level. Hence, the null hypothesis H dot will be rejected. The coin is unbiased. Okay, in this way you have to write. So you listen carefully here. In calculation part, see 400 into 1 by 2 into 1 by 2, you will get 10. So difference is the 240. So 240 indicates heads. See, out of 400 times, when we tossed a coin, we got 240 are heads. That is the probability of success. Probability of success minus 200. 200 is the half value is equals to 40. So in this way, you have to write the conclusion. Any doubt?
No, sir.
Okay. Then next more problem. In 324 throws of a six-faced dice, odd points appeared 180 times. Would you say that the dice is fair at 5% level of significance? See, 300 24 times a dice is thrown. Fixed phase dice is thrown. So odd points appeared 180 times here. Odd points appeared means this is the probability of success. See, LOS value is given. 5% LOS value is given. Clear. Okay. Setting hypothesis A, null hypothesis, B, alternate hypothesis. H naught, mu is equal to H naught, kind is unbiased. Then HA, mu is not equal to HA, rejected. In setting suitable significance level, so 5% is given in the question. So consider only A, that is at 5% significance level, 95% confidence level, that is 1.96. Then test criterion, standard error of number of success is equal to under root NPQ. N is equal to size of sample, P is equals to probability of success, Q is equals to 1 minus P, that is probability of failure. So doing calculation, so here you observe carefully in doing calculation. When the dice is fair, the probability of getting of even numbers would be equal to odd numbers. See, to confuse the student examiner, okay, what he is using the word even numbers and odd numbers. For a dice, how many even numbers are there? Same odd numbers will be there. 1, 2, 3, 4, 5, 6. 6 faced dice will be there. So 1, 3, 5 are the odd numbers and 2, 4, 6 is the even numbers. So that is half of value. So out of this here, hence 324 crores of dice, we expect 324 into 1 by 2 is equals to 162 odd points and even points. The difference is equals to 180 is the odd points. Already we got in the question 180 minus 162 is equals to 18 is the difference. Standard error of number of success is equals to under root NPQ. N is equals to 324, P is equals to 1 by 2, Q is equals to 1 minus P, that is 1 minus 1 by 2 is equals to 1 by 2. So converted into the principle, standard error number of success is equals to under root NPQ. Okay, 324 into 1 by 2 into 1 by 2 is equals to under root 81 is equals to 9. The calculated value, standard error is equals to difference divided by standard error number of success. Okay, so that is a 18. Okay, 18 divided by 9 is equals to 2. So here decision is like this, right? The calculated value 2 is greater than the table value of 1.96 at 5% significance level. Hence, the null hypothesis H naught will be rejected. Okay. So one more question is there. Okay. So fourth problem, you observe carefully. Person throws 10 dice. See here 10 dice are there 500 times and obtains 2560 times 246. Can this be attributed to fluctuation of sampling? Give the decision making rejected or accepted. Do the decision making rejected or accepted. That is setting hypothesis. A, null hypothesis. B, alternate hypothesis. Dice are unbiased. They are rejected. Okay. So 5% is given or 1% is given. You observe the question, nothing is given. So consider only 5% only. That is 1.96. Okay. Test criterion. Standard error number of success is equal to under root NPQ. N is equal to size of samples. P is equal to probability of success. The Q is equal to 1 minus P. That is the probability of failure. So doing calculation. In doing calculation, you observe carefully here. When the dice is fair, the probability of getting number 246 numbers would be equal to 135 numbers. That is 1 by 2 of value. Hence, 5,000 throws of dice. We expect 10 into 500 is equals to 5,000 into 1 by 2. That is 2,500. 2, comma 4, comma 6 points and 1, comma 3, comma 5 points. So difference is here 2,560. 2,560 is given in the question. That is the dice, the probability of success. Okay, minus 2,500. Okay, here 10 dice are there. See, this step is important here. 10 dice are there. 10 dice into 500. That is 5,000 into 1 by 2. That is 2,500. Okay, 2,500 here. Okay, so 2,500 into 2,560 minus 2,500 is equal to 60. 60 is a difference value. So converted into the principal, standard error number of success is equals to under root NPQ. So here 5,000 into 1 by 2 into 1 by 2 is equals to under root 1250 is equals to 35.35. 35.35. Okay. So calculated value is equals to standard error. Difference divided by standard error number of success is equals to 60 divided by 35.35 is equals to 1.697. So decision is here like this. We have to write the calculated value 1.697 is less than the table value of 1.96 at 5% significance level. Hence, the null hypothesis is accepted. Dice is fair. Okay, so these are the four problems. And one more problem is there, it is not required. So the next method is here, test for proportion of success. In this chapter only, under number of success, the second one here, test for proportion of success. Any doubt in this method?
No, sir.
Okay. Dice ప్రాబ్లము దెన్ కాయిన్స్ ప్రాబ్లమ్ ఇస్తారమ్మా ఇందులో చాలా జాగ్రత్త చూడండి. సో టెస్ట్ ఆఫ్
Oh,
సిగ్నిఫికెన్స్ ఫర్ అట్రిబ్యూట్స్. Okay, in the first method we completed test for number of success we completed. And now test for proportion of success we are going to do now this method. Okay, in the first method dice problem as well as kinds problem will be we are going to get the questions. So just focus on the probability of success only. Don't focus on probability of failure. Okay, I'm moving to the second method. This is the test for proportion of success. Next I'm going. Okay. So test for proportion of success. So here, see, listen carefully. Instead of recording the number of success in each sample, we may record proportion of success. The following is the formula used to test the proportion of success. That is standard error. Standard error proportion of success. Okay, the following is the formula. So under root PQ by N. In the previous formula, standard number of success, the formula what we written? Under root NPQ, but here under root PQ by N. Probability of success into failure by N. So P is equal to probability of success and Q is equal to probability of failure. That is 1 minus P. Then N is equals to number of total samples. So calculated value principle like this here. P plus or minus 3 under root PQ by N into 100. P plus or minus 3. Okay. Under root P plus or minus 3 into under root PQ by N into 100. So that is one, number one. See, first problem. ఓకే ఫస్ట్ ప్రాబ్లం చాలా జాగ్రత్త చూడండి అమ్మా. చాలా సింపుల్ ఉంటుంది ప్రాబ్లం, ఇబ్బంది లేదు. చెప్పిన ప్రాబ్లం మళ్ళీ 2 times రిపీట్ చేస్తాను, మీరైతే చాలా జాగ్రత్త వినండి. సో 500 యాపిల్స్ ఆర్ టేకెన్ ఎట్ ర్యాండమ్ ఫ్రమ్ ఏ లార్జ్ బాస్కెట్. ఓకే, అండ్ 50 apples, 50 are found to be bad apples in the basket. Assign the limits within which the percentage most probably lies. ఓకే, సో హియర్ ఇన్ దిస్ క్వశ్చన్ ఇస్ క్లియర్. క్వశ్చన్ చాలా జాగ్రత్త చూడండి. 500 యాపిల్స్ ఉన్నాయట పెద్ద బాస్కెట్ లో. సో ఇన్ ఏ బిగ్ బాస్కెట్ 500 యాపిల్స్ ఆర్ దేర్. సో యూ వెంట్ టు వెజిటేబుల్ ఫ్రూట్స్ మార్కెట్ అండ్ వెజిటేబుల్ మార్కెట్. సో యూ ఆర్ గోయింగ్ టు పర్చేస్ టమాటో యాజ్ వెల్ యాజ్ apples. Okay. So in a big basket, how many apples are there? 500 apples are there. 500 apples are there. Wait a minute. So 500 apples are there in a big basket. Okay, 500 apples are there in a big basket. So out of 500, 50 apples are found bad apples. 50 apples are found to be bad apples. So assign the limits within which the percentage most probably lies. So these 50 apples, see generally in the basket, how many trays will be there? Generally 500 apples are there. So in the tray 1 50, in the tray 2 50, in the tray 3 50. In this way, sometimes 10 trays are there, self like we can say, or 50 trays will be there. For each tray, 10 apples will be there like this. So these 50 bad apples are there between, whether it is there in the first tray or second tray, third tray, fourth tray, fifth tray, sixth tray, seventh tray, we don't know. So we have to find out the bad apples where it lies. So with this problem, we are going to get that information. So here the solution is here. The probability of bad apples is given. Okay. So here this is a sample. This is a success. We need to get the probability of success. It is 50 divided by 500 is equals to 0.1. The proportion of bad apples in the given sample is equals to 50 divided by 500. That is 0.1. So hence P is equals to 0.1. Then Q is equals to 1 minus 0.1. That is failure. 0.9 is the failure. So success is 0.1 and failure is 0.9. Then N is equals to 500. So convert it into the principle, that is standard error of proportion of success is equals to under root PQ by N. Okay, PQ by N. So P value and Q value we know. P value, Q value is we know. So P value is here 0.1 and Q value is here 0.9. Okay. So after converting into the principle, standard error proportion of success. Standard error proportion of success. See, standard error proportion of success is equals to under root PQ by N. That is under root 0.1 into 0.9 by 500. Okay. So here you will get 0.1, 0.013. 0.013 is the final answer. So after getting these answer, say after getting these answer, the limits within which the percentage of bad apple lies. So limits is that where actually the bad apples are there. So here this is a formula. Calculated value is equals to P plus R minus 3. Plus or minus indicates plus or minus. Plus or minus means first we have to do with plus sign and second we have to do with minus sign. P plus or minus 3 under root PQ by N into 100. That is, okay, P place low in this call is 0.1. You observe carefully this step here. 0.1 plus or minus 3. See, under root PQ by N. How much we got answer? 0.013 into 100 into 100. Okay. 0.1. P plus or minus 3. So first we have to do with plus sign. That is 0.1 plus 0.039 into 100. That is 0.1 plus 0.039. That is 0.13 into 100. That is 13.9. 13.9. So 13.9 you have to write. Don't write upper limit or lower limit. After finding the next value only, we have to decide that this 13.9 is upper limit or lower limit. Okay, so first we completed the first part with the plus sign we done. Then with minus sign we have to do. See 0.1 minus. See here we done plus. So we need to do with minus 0.1 minus 3 into 0.013 into 100. 0.1 into 0 minus 0.039 into 100. Okay, 0.06 into 100. Finally, you are going to get 6.1. 6.1. So this is a big number and this is small number. So you have to, now you need to write lower limit and upper limit. Okay, are you getting my point?
Yes.
Okay. So here the proportion of bad apples in the consignment almost certainly lies between 6.1 and 13.9. So in this way we have to find out. So these bad apples out of 500. Okay, after reaching home, today is a Sunday, so you went for fruits market, you purchased big basket. In that big basket, you estimated that 500 apples we required. So you, why? Because some function is there in your house. So you have some leisure time on Sunday. That is the result you went for fruits market. So you purchased 500 apples in a big basket. So here 50 bad apples. After reaching home, you pick up whether all the apples are in a good condition or not. So you went for searching. So you pick up one by one, one by one. So finally you found that 50 bad apples are there in that big basket. So in which tray it is there are there means 6.1. So from sixth tray to 13.9 tray, in between 50 apples are there. Why? Because 1, 2, 3, 4, 5 till 5 trays all apples are very much good. Why? Because customer after reaching the fruits market, he will pick up and he will open sometimes. He have some doubt. He will open in the basket and he will check the first tray. Again, he will be getting the doubt. He will take some risk to open the second tray. The second tray also good. And the third tray, he will take a decision to open or not. Okay, 99%, the person never go for the third try. Why? Because first try and the second try will be the deciding factor. So based on the first try and second try, he think that remaining trays also all the apples are in good condition. But after reaching the home, what happens? 50 bad apples are there. So in this way, we have to find out. So tray number 6.1 to 13.9. In between these trays, 50 bad apples are there. So the proportion of bad apples in the consignment almost certainly lies between 6.1 and 13.9. Okay, in this way, you have to write the answer. Okay, anybody any doubt?
No, sir.
Doubt ఉంటే అడగండమ్మా.
Clear, sir.
Okay. So next we are going to the next problem. You observe next problem carefully. Okay, are you going through the next question?
Yes, sir.
So in the first question, 500 apples we purchased, but 50 apples are found to be bad apples. So in this question, what is the question? Anybody can you read?
Thousand. Yes, sir.
Okay.
1,000 mangoes are taken at random from a big basket, and 100 are found to be bad. Estimate the proportion of bad mangoes in the basket and assign limit within which percentage most probability lies.
Okay. Right. So what you understood by reading this problem?
Percentage find out చేయమంటున్నారు కదా సార్, విత్ ఇన్ విచ్ పర్సెంటేజ్ మోస్ట్ ప్రాబబిలిటీ లైస్ అంటున్నారు. 1,000 మ్యాంగోస్ లో 100 డ్యామేజ్ అయ్యాయి.
Hmm.
ఎస్టిమేట్ ద ప్రపోర్షన్ ఆఫ్ బ్యాడ్ మ్యాంగోస్. లిమిట్ విత్ ఇన్ విచ్ పర్సెంట్.
Okay. So here, see, in the previous problem, 500 apples, we got 50 bad apples. So in this problem, 1000 mangoes are taken at random from a big basket. Okay. 100 are found to be bad. See, పెద్ద basket లో 1000 mangoes తీసుకున్నారట. 100 బ్యాడ్ మ్యాంగోస్ ఉన్నాయి. సో ఈ బ్యాడ్ మ్యాంగోస్ ఏ ప్లేస్ లో ఉన్నాయో మనము లిమిట్స్ ఫైండ్ అవుట్ చేయాలి. సేమ్ ప్రొసీజర్. ఇన్ ప్రొసీజర్ దేర్ ఇస్ నో చేంజ్. అక్కడ 500 ఇచ్చాడు, 50 ఇచ్చాడు. ఇక్కడ 1000 ఇచ్చాడు, 100 ఇచ్చాడు. సో ఫస్ట్ వీ హ్యావ్ టు డిసైడ్ ది సక్సెస్. ది ప్రపోర్షన్ ఆఫ్ బ్యాడ్ మ్యాంగోస్ ఈస్ గివెన్. Mangoes in the given sample is equals to 100 divided by 1000, that is 0.1. Okay, here P is equals to 0.1, Q is equals to 1 minus 0.1, that is 0.9. Converted into principal, standard error proportion of success is equals to under root PQ by N, okay, is equals to under root 0.1 into 0.9. 0.1 into 0.9 divided by N, that is 1000. Okay, so here, see, 0. Okay, so 0.0094. Okay, the limits within which we got the uh, under root PQ by N value is 0.0094. The limits within which percentage of bad mangoes lies is equals to P plus or minus 3 under root PQ by N into 100. So 0.1 into plus or minus 3 into 0.0094 into 100. Okay, so for the first time we have to do with plus, and for the second time with minus. So plus, see, 0.1 plus 3 into 0.0094 into 100. So you will get a 12.82, that is upper limit. 12.82 is upper limit. Then next with minus. 0.1 minus 3 into 0.0094 into 100. Okay, that is 7.18, lower limit. So the proportion of bad mangoes in the consignment almost lies between 7.18 and 12.82. ఈ ట్రేలో ఉందట. 7.18 నుండి స్టార్ట్ చేస్తే 12.8 ట్రేలో ఆ మధ్యలో 5-6 ట్రేస్ లో 100 బ్యాడ్ మ్యాంగోస్ ఉన్నాయట సార్. ఓకే, సో ఇన్ దిస్ వే వీ నీడ్ టు ఫైండ్ అవుట్. సో ఎనీ డౌట్?
నో సార్.
ఓకే, సో విల్ సీ ద నెక్స్ట్. So that is the second method. First method is number of success. Second method is proportion of success. Then the next method is difference between proportion of success. Difference between proportion of success. Number of success in doubt unda under root PQ by N. Under root N into P into Q. That is formula. Then next one is under root PQ by N. లిమిట్స్ అని అన్నాడు అనుకోండి క్వశ్చన్ లో ప్లస్ ఆర్ మైనస్ వాల్యూ తోటి మనం చేయాల్సి ఉంటుంది ఫార్ములా ప్లస్ ఆర్ మైనస్ ఉంటుంది ఓకే దెన్ టెస్ట్ ఫర్ డిఫరెన్స్ బిట్వీన్ ప్రపోర్షన్ ఆఫ్ సక్సెస్ టెస్ట్ ఫర్ డిఫరెన్స్ బిట్వీన్ ప్రపోర్షన్ ఆఫ్ సక్సెస్ ఇస్ దేర్ సో హియర్ టెస్ట్ ఫర్ డిఫరెన్స్ బిట్వీన్ ప్రపోర్షన్ ఆఫ్ సక్సెస్ ఇఫ్ టూ samples are drawn the difference between okay so if two samples are drawn if two samples are drawn the difference between the proportion of success difference between the proportion of success population, we may be interested in finding out whether the difference between the proportion of success is significant or not. In such a case, we take the hypothesis that the difference between P1, that is the proportion of success in one sample, P2, the proportion of success in another sample, is due to the fluctuation of random sampling. The standard error of difference between proportions is calculated by the applying following formula. So here P1 value and P2 value we need to find out. So always P indicates probability of success and Q indicates probability of success. So we need to find out the probability of success two times here. Proportion of success two times here. So this is a formula. Standard error P1 minus P2 is equals to under root PQ into 1 by N1 plus 1 by N2. 1 by N1 plus 1 by N2. Okay, so where P is equals to the pooled estimate of actual proportion in the population, the value of P is obtained as follows. P is equals to, see, to get the P value, this is the formula. P is equals to N1 into P1 plus N2 into P2 by N1 plus N2. Okay, N1 into P1 plus N2 into P2 divided by N1 plus N2. So here R P is equal to X1 plus X2 by N1 plus N2. So based on the condition, based on the situation, but just consider this one only to get P value. This value should, this formula will be applicable. Then if P1 minus P2 by standard error, P1 minus P2 is less than 1.96, that is 5% LOS. The difference is regarded as due to random sampling variation, that is as not significant. Okay. So we'll see the problem. See, in this problem, proportion of success means two villages or two consumers will be there here. So in this problem, you listen carefully. In a random sample of 1000 persons from town A, okay, is a random sample of 1000 persons from town A, 400 are to be consumers of wheat. Out of 1000 persons, 400 persons are to be the consumers of wheat. In a sample of 800, in a sample of 800 from town B, 400 are found to be 400 are found to be consumers of wheat. Do these data reveal a significant difference between town A and town B so far as the proportion of wheat consumers is concerned? Okay, town A, town B, random sample and consumers of wheat. So in this way, the information is given. So setting hypothesis, that is null hypothesis H naught, mu is equal to H naught. No difference between town A and town B. Alternative hypothesis HA, mu is not equal to H naught, HA, that is rejected. In setting suitable significance level. At 5% significance level, 95% is confidence level, that is 1.96. So test criterion, that is a standard error. P1 is equal P1 minus P2 is equals to under root PQ. P into Q into 1 by N1 plus 1 by N2. Okay, this is the formula. So to know the p value, see p value find out చేయడానికి మనం ఏం చేస్తామంటే p is equals to n1 into p1 plus n2 into p2 divided by n1 plus n2. Then q is equals to 1 minus p. Okay, so doing calculation. So listen carefully. The calculation part is most important here. Calculation part. P1 minus P2 is equals to under root PQ into 1 by N1 plus 1 by N2. Okay, so P1 is equals to, say, out of 1,400 are the consumers of wheat. 400 divided by 1,000 is equals to 0.4. Then P2 is equals to 400 divided by 800. That is 0.5. Okay, so P is equals to N1 into P1 plus N2 into P2 divided by N1 plus N2. So P is equals to N1. N1 is 1000. Total random sample is 1000 into 0.4, that is P1. See, already the value we got. ఇక్కడ value ఉంది ఇక్కడ చూడండి 0.4 plus 800 into 0.5 divided by 1000 plus, that is N1 plus N2, 1000 plus 800. So P is equals to 400 plus 400 divided by 1800 is equals to 800 divided by 1800, that is 0.44. This is the probability of success value. So Q is equals to 1 minus P, that is 1 minus 0.44 is equals to 0.56. So standard error P1 minus P2 is equals to under root PQ into 1 by n1 plus 1 by n2. 1 by n1 plus 1 by n2. Okay. Say 0 under root 0.44 into 0.56. The p value is 0.44 and the q value is equal to 0.56 into 1 by n1. N1 is 1000 plus 1 by n2. N2 is 800. So final the answer is 0.0234. So calculated value. Okay, calculated value is equals to P of P1 minus P2 divided by standard error P1 minus P2. That is 0.4 minus 0.5 divided by 0.0234 is equals to 4.27. 4.27 is the calculated value. So the calculated value 4.27 is greater than the table value of 1.96 at 5% LOS. Hence, the null hypothesis H naught will be rejected. So in this way, we have to calculate. Okay, this is a proportion of success problem. So only one problem is enough for your examination point of view. And one more problem you can see. See, before an excise, before an increase in excise duty on tea, 400, okay, people out of a sample of 500 are found to be tea drinkers. After increase in duty of 400 persons taken, tea drinker in a sample of 600. Okay, before an increase in excise duty, 400 people, say listen here, out of sample 500 tea drinkers. 400 టీ డ్రింకర్స్ ఉన్నట అవుట్ ఆఫ్ 500. దెన్ 600 లో 400 అంటే ఉన్నారట టీ డ్రింకర్స్. ఇంక్రీజ్ కాకముందు ఇంక్రీజ్ అయిన తర్వాత ఆఫ్టర్ ఇంక్రీజింగ్ ఎక్సైజ్ డ్యూటీ. ఓకే, బిఫోర్ ఇంక్రీజింగ్ అండ్ ఆఫ్టర్ ఇంక్రీజింగ్. సో ద సేమ్ ప్రాబ్లం. Setting hypothesis, setting suitable significance level, test criteria, doing calculation. ఓకేనా? ఎనీ డౌట్? స్నాప్ తీసుకోండి, ఫోటో తీసుకుందాము. ఫోటో తీసుకొని ఇంటికాడ చేయండి ఈ ప్రాబ్లం. ఈ ఫోటో తీసుకోండి, ఇంటి దగ్గర చేయండి ఈ ప్రాబ్లమ్ని. చేసిన తర్వాత మీకు ఏమైనా డౌట్స్ ఉంటే మాత్రం నెక్స్ట్ క్లాస్లో నెక్స్ట్ సాటర్డే సాల్వ్ చేస్తాం. కంపల్సరీ
Okay.
ప్రాక్టీస్ చేయాలి. ఇఫ్ యూ డూ ప్రాక్టీస్ దెన్ యూ ఆర్ గోయింగ్ టు గెట్ ద డౌట్స్, అదర్వైజ్ యూ నెవర్ గెట్ ద డౌట్స్. Proportion of success, in proportion of
Okay.
success, two activities will be there. Okay, then next is తీసుకోండి. The next this one. Okay, one more question is there. So for your practice purpose, so I will ask the answer on the next class. ఓకే నెక్స్ట్ క్లాస్
Okay.
లో ఆన్సర్ అడుగుతాను ఈ క్వశ్చన్ తీసుకోండి నేను చదువుతా వినండి జాగ్రత్తగా ఇన్ ఏ సింపుల్ ర్యాండమ్ శాంపిల్ ఆఫ్ 600 men taken from a big city 400 are found to be smokers. In a simple random sample of 600 men taken from a big city 400 are found to be smokers. In another simple random sample of 900 men taken from another city, 450 are smokers. See, in one city, total 600 randomly we pick up. ఒక సిటీలో 6,000 మెంబర్స్ ఉండొచ్చు 6 lakhs ఉండొచ్చు బట్ ఫ్రమ్ దట్ 600 మెంబర్స్ we have chosen. Okay, but we found that 400 are found to be smokers. In another sample, 900 men are taken, 450 are smokers. ఓకే మీకు ఆన్సర్ నేను కింద స్క్రోల్ చేస్తున్నా కానీ మీరు నేను మీకు ఫోటో తీసుకోకుండా బట్ మీరు చేయండి ఇంటికి సో అనదర్ ప్రాబ్లం ఇన్ ఏ ర్యాండమ్ శాంపిల్ ఆఫ్ 1,000 persons ఫ్రమ్ యూపీ 510 were found to be consumers of cigarette. In a random sample of 1,000 persons from Uttar Pradesh, 510 were found to be consumers of cigarette. In another sample of 800 persons from Rajasthan, 480 were found to be consumers of cigarettes. To discuss the data revealed a significant difference between UP and Rajasthan so far as the proportion of consumers of cigarettes is concerned. Okay, this is another problem. So at this, we completed that chapter. Okay, remember, test for significance of attributes and test of significance for variables. This is another chapter. So two more questions are there. So please note down these questions also. Please take a photos. There are 1,000 students in a college out of 20,000 in a whole university in a study. Okay, 200 were found smokers in the college and 1,000 in the whole university. Is there a significant difference between the proportion of smokers in the college and university? Okay. In a sample of 300 units of manufactured products, 65 units were found to be defective, and in another sample of 200 units, there were 35 defective. Is there a significant difference in the proportion of defectives in the two samples at 5% level? Okay. So at this, we completed this chapter. So in the tomorrow class, tomorrow in the sense, the next class, we'll start a test of significance for variables that is large samples. So number of success, any doubts? Anybody? And difference between proportions, any doubts? And proportion of success, any doubts? In a number of success, we are going to face the problem like a dice problem and coin problem. And difference between success, limits problem. Okay. The difference between proportions. The proportion of success. Proportion of success, we are going to see two types of activities, before and after, and two cities in this way. Okay. So if you have any doubt, you can ask the doubts. Anybody? The doubts ఉంటే అడగండి అమ్మా. Okay. Right.
Clear.
Right. So it's already 11:30. So I'm leaving the class. So for the next class, what homeworks I have given. So please come with homeworks.
Okay. Thank
Uh,
you.
okay. Right. Thank you.
Thank you, sir.
Okay. Thank you all.